0.8012, comma 59.1988. Chances are it's going to be like 1 decimal. Yep. 24.8 is your lower. Your higher is going to be 59.2. We're number 8. Cool. Oh, let me refresh this. N is 17. They had a mean of 96.6, standard deviation of 24.3, 98%. It's a whole lot of numbers. I actually don't feel like doing the math. Grab your calculator. Second, stat. I lied. Stat. Tests. Down to number 8 where it says T interval. Click it. You're going to get the option between data and stats. You're going to click stats. And you're going to fill things in as I did. So X bar will be 96.6. Your SX, or standard deviation, is 24.3. Your N is 17. And your C level is critical value, which is 0.98. Because 98% is the same thing as 0.98. You calculate, and it gives you your numbers. 1 decimal. Your lower is going to be 81.4. Your higher is going to be 112. Oh, whoops. 1.8. Said round to 1 decimal place. Oh man, this time we can't do a little trick on. Bummer. How many subjects are needed to estimate the average number of books in America's read with a margin error? Blah, blah, blah. Okay, we don't have an N. We don't have a number. But they're willing to give us an error, a margin of error of 0.79 and 90%. Population standard deviation is 5.8. Okay, some things. Oh, my bad. Some things to keep note on are the initial results of the Gallup poll indicate that the population standard deviation is 5.8. If the population standard deviation standard deviation is given, you solve for the z-score. If the population standard deviation is not given, you use t-score. Understand the difference. 90% is, where did my list go? So I'm not trying to do the math. 90% gets translated to 1.645. And we are solving for N. Standard deviation is given, so we're going to use a z-score times your standard deviation over n squared. This is the same thing as saying, but where does that guy go? Something's not right. Hold on. No, there it is. Whoops, wrong formula. My bad. I'm a little bit tired. Actually, that was correct. Right there. So our n equals our z-score times standard deviation, which is this guy, times 5.8 squared. Whoops, the whole thing gets squared in the end, divided by your margin of error. And all that gets squared. Remember, E is this guy. So E is 0.79. So parentheses 1.645 times times 5.8 divided by 0.79. Yep. You take enter, second, whoops. Take your answer and then you square it. And we are left with 145.8, but it wants to round up because it's people. Me number American, but whatever. It says round up to the next whole number, so it'll be 146. Awesome possum. 2 more to go. Then I get some sleep. Oh man, one of these. However will we do it? Let me show you. Your calculator, stats, edit, clear list 1. If you don't know how to clear list 1, you click the up arrow, clear, enter. Alright, now you just enter in all the values. Cool. Click stat again. Go to tests. Go down to T interval. This time you're going to switch it to data, not stats. List 1, frequency 1. Your critical level is 90% or 0.90. Calculate. Amazing. Does it give us everything though? No. Cool. We have to do that manually. It did give us our sample standard deviation of 9 point, it wants 2 decimal places, 33. Cool. Let me write down what it gave us. It gave us our X bar of 36.286. Our standard deviation, no. Our S is 9.326, and our N is 14. N is 16. Amazing. What are these numbers? Well, unfortunately, you're going to have to find a chart. The chart is called chi-squared distribution. The one I have is Formulas and Tables by Mario F. Triola. Triola. Trolla. The way it works is you take your standard deviation. Your standard deviation. And no. You take your percentage and your n, which in this case is 16, minus 1 to find your degrees of freedom, and you just match it up with a chart. That's what I'm messing up. I forgot how to do. Okay, cool. Let's get math in. 1 minus 0.9 is 0.1 divided by 2 is 0.05.